that's what's important in the end, isn't it?
It is. Well, hello, everyone. Claudia and I are talking. And so, welcome. This is the Physicist and Philosopher Hour. My name is Wayne Steiger, the philosopher, and the physicist is Dr. Claudia Albers. Hello, Claudia. How are you?
I'm fine, thank you, Wayne. And how are you?
Doing good, doing good. Living in the moment, and the moment seems to always be changing.
Yes.
We
At
were,
least it's not as cold this week. At least
see,
not for me.
that's what we were talking. Well, I just want to say hello to all of the moderators. Thank you. Kaz, man, it's like 2 o'clock in the morning over there. That's Great Britain. There's Carol. How are you doing? Mary, good to see you, dear. Lots of people here, Claudia. Uh,
That's
just want to
wonderful.
welcome all, one and
Yeah.
all. And so, yes, it was cold last week. Wasn't too bad here. Y'all over on the East Coast got more of it than we did.
Mm-hmm.
Hmm.
Yes,
Yeah.
it was very cold here, but it's warmed up. It feels like spring at the moment.
I don't think that's going to be long lasting. I just got this sneaky suspicion that
Yeah.
at some point in time, Scott is going to be out there shoveling snow and, wondering,
Mhm.
it's inevitable. It's inevitable. Right before we came on, Lynn was showing me a story in Lake Tahoe and Nevada, that area up there. Are you ready for this? 9 feet of snow
Oh my goodness.
out of this last storm. 9 feet. Well, I just want to say hello to everyone, folks. So good to see you, Abilene, Texas. Claudia, we got people all over the world. And Claudia, you and I were talking about, the Daily Times are showing our shows, and
Hmm.
we say show away. We say go for
Yeah.
it. Our faces, well, they're noticeable. So we just appreciate the free
Yeah.
exposure and thank you.
Yes, we're getting a wider audience. That's a
I
good
think
thing.
so. Yeah, yeah. So, that's what we're here about, to discuss and give points of view that normally you would not find on other channels or other sources.
Hmm.
Would you say that would be appropriate?
Absolutely.
Yeah,
Absolutely. Definitely. I think we have a unique point of view.
I think we do too. And that is a good thing. Because you know what? Claudia, when you look at it, our world is unhinging. No matter how positive, no matter how bright you want to make the future, there are just some things that are happening. And speaking of that, we've had some of our um, subscribers and viewers send us some pictures. I have one pulled up here,
Mhm.
Claudia, that I
Okay.
think you're going to find.
Sounds good.
This is from South Dakota, I believe, today.
Hmm.
And
Yes.
yeah, there it is. I mean,
That's the sun halo. I've written a lot about these sun halos. I know exactly what they are. And the only way to produce a sun halo is artificially, even though the accepted view is that it's ice crystals in the atmosphere. As I have shown in many articles, it's completely impossible for these to be made by ice crystals. You would just there's no way you can ice crystals can refract light so that it all comes out at exactly the same angle because they have a flat surfaces, and it's just impossible. It's completely illogical. The only way you can create these is artificially,
and
and that means you have a sun simulator and a lens in front of it, a converging lens like a magnifying lens, and then you have light coming from other simulators from the edges. And at the edges, the light is bent, and that causes refraction. And it results in that halo effect. And the thing is, these have been happening for at least centuries.
mhm.
because we have paintings with these on. And that means that these have been used in our atmosphere for centuries. And we haven't had the technology to do it. So it has been aliens using their alien technology that have been doing this. And I think what they've been doing is hiding the fact that the sun, even centuries ago, was now and then going dark. They always taught us that it's impossible, but obviously it was. It was going dark for small periods of time, and they were using these simulators to hide that from us.
I find it odd too, Claudia, that you look on the refraction of the sundogs, as they call them. I find it odd how you can get in such a short radius. I can get such a variance of it. I think it's about 3 degrees. If I look over here and I look to here, if I use this as the ecliptical plane I would be looking at, that's just odd.
Yeah, it's not. It cannot be naturally produced. It's just impossible. If you have ice crystals in the atmosphere, they will have different orientations to each other. They will be at chaotic kind of orientations. So the light will come out of, if they go through an ice crystal, at different angles. They will never come out at exactly the same angle, which is what you would need to produce something like this in the atmosphere.
By the way, I just want to give recognition and credit to Bobby. Bobby said, absolutely, go ahead. So Bobby, I won't give your last name, Bobby, but thank you. Now, I've got something here, Claudia, that I think, this is from Sin. I think she goes by Hopkinson on her handle. I just absolutely so appreciate her work. Claudia, she is just diligent. She takes a look at the webcams, particularly down in Mexico. And what she has done, as you can see here, she has collected year to date. So this was a year ago. Please take notice of where the sun is at. You can actually see the date. I'm going to try to pull it up here. Yeah, you can see it's 2018 with. All right, so here is the sun. Are you ready for something?
Yeah, well, is the sun this large? It's not
Oh,
supposed to be this large. That's the first thing.
then wait till you see the next thing. Exact same day, 1 year later, the sun has moved. It is, and check this out, Claudia. It's here now. It was over here. Look over the two pictures. Here, here.
Yeah, I mean, they don't put the sun in the right places. I mean, I've even caught it changing from, I mean, two suns in the sky, two different positions. It was actually changing over because one had a black dot in the center and the other one didn't. So they changed the position of the sun. They're not very careful about where they place the sun. And we know why that is the case. That is because there is no actual real sun to cover up. They think, well, as long as there is something up there which people recognize as the sun, we're fine.
Well, I have something more to show you. And it's odd that we're in at Mexico because I didn't know. I did this on, I believe it was Saturday. Yeah. So there is where you can go and see the live shot of the volcano. Mexico has several of them. So I went and spent several hours, like I didn't have anything better to do, but I did. But Claudia, check this out. So can you see our volcano?
Yes.
Okay. I'm going to go ahead and start playing it. So this is our volcano, and I'll advance it because this is several hours. I just want you to start watching something. There we go. Watch where the sun is. And this is going to be the most remarkable thing. Seriously, this gets very weird, Claudia. So the volcano is there. It's now what we see is a buffering, and this is what you see a little bit in the distortion. It's a buffering of the video, but it does not account for what we're about to see. This has got really, really weird. So let's just continue to let the video play because it brings in the effect of about what you're about to see. Because I actually showed this to my wife and she said, well, that she says is very odd.
Well, the sun is getting very pointy, isn't it?
It seems to be, doesn't it?
And you can see it's got a pink edge. That's clearly not the real sun. The real sun doesn't have a pink edge around it. That's the first thing.
Well, and it gets even more.
And it's not pointy. The real sun is perfectly circular.
Yeah, this gets really weird. And now it's retreating. This is what I couldn't figure out. And I'm looking at this and I'm going, but wait a minute. It's going back retrograde. Now that, see, I'm not doing anything to it. This was the video directly from the webcam.
I would think this is not actually the sun we're looking at, but it may not even be a sun simulator either. It may be one of these objects that are coming in, especially the larger ones, that actually induce volcanic eruptions.
Wait till you see this. We saw the sun was going on a clear trajectory as it should have. This was the weirdest thing. I looked at this all on Saturday when I was recording it, and I'm going, well, now this doesn't make any sense. So listen, it's still going. The video is still. So here's another anomaly. What is the sun doing out of frame? It's there for approximately about 30 minutes, which is kind of unusual because anyone who watches the sun track across the sky knows that it moves rather quickly, or supposed to be.
Yeah, and the sun just remained over the volcano. It became pointy and actually pointed towards the volcano.
Yeah. And then it went up.
This suggests this is actually one of these objects, because that's how I would expect them to behave. If they have plasma on them, that they actually are attracted to the magma inside the volcano. And there's a sort of an electrical reaction on the magma that it has on it. And it sort of points towards that. So that would suggest it's actually an object up there, not even a sun simulator.
Do you see? And, so wait till you see what happens here. This I was so busy reading and doing other research. I was going to send this to you because I couldn't quite. You and I have talked to this for years and years. I'm a pretty sharp observer, as you are, and I'm going. Now this is something that's not going right here.
This is amazing observational evidence that you have just caught, Wayne.
Look what's coming down now, Claudia. We just saw this, and the thing about it is, if you run the video back, we're into 16, 15, 17 minutes since it went up.
And it's still there.
and now it's coming back down. And
oh my goodness.
You see the size of this. If this is our sun, we just showed a picture from South Dakota. Now, I get the understanding of the globe that there would be a difference in the degrees. I get that. But we just saw the gentleman shoot the sun as it was in the horizon setting. It ain't looking like this, Claudia. Wait till you see this. I know this takes a little bit of time, folks. Just bear with us. It's worth the observation. Because this is what you have taught me as a physicist, is that observation is really key to all science. Isn't it?
Absolutely. It's the basis of physics is observation.
So this camera doesn't move. You can go over on there. They have a YouTube channel. And this sun, folks, Claudia, it's not acting right.
This is not the sun. This cannot be the sun. It's impossible. The sun, not even a sun simulator would act like this. A sun simulator sometimes move faster than at other times. But never remain stationary, go up and then come down again, become pointy and point towards a volcano. A sun simulator does not do that.
And folks, what you're seeing a little shifting in the picture is because I'm advancing this at 3 times normal speed. So that's why you're seeing the shift in the frames. But Claudia, here's where it blew my mind. Whatever this is, if this is the sun, then holy crap, it doesn't act like the sun. And you know what I also found in this thing? It's flashing.
Uh-huh.
Watch it. It actually flashes. You see it?
Yes.
And it's almost as if you can see the bird that flies through it. So we know that the camera is staying stationary. It's just merely filming what it's pointed at is the top of this volcano.
It's amazing.
Now, this volcano, by the way, Claudia, is also where we've captured the UFOs coming out of.
Oh.
So is this something that you can go, well, is there a connection? And again, so what are we looking at? In Mexico, the sun would be heading back towards the equator, right? It's now moving from the south, moving north.
Yes.
But Mexico.
What time of day was this?
This is, and it is in the frames. I think this is like 3 o'clock in the afternoon.
Okay, so the sun was supposed to be setting and therefore going down towards the horizon.
Yes.
But what we saw, it came down first and then it went up and then it came down again. It became pointy. This is not the sun. That's impossible.
It's just weird. I mean,
what I mean is it's not even a sun simulator. There's no way a sun simulator would act like this.
Yeah, and then when you begin to look at the frame, and I know folks that, and I'll try to advance it a little bit faster for us here. See if we can get it going. So allow me just to pull it up here a little bit more. All right. I want you to start seeing are you seeing what's happening here?
Wow.
Are you seeing what's freaking happening here? Look at that, Claudia. Is that not the most, I mean, if that's our sun, all right, but this thing it didn't act like our sun.
No, it didn't.
And now you can see what's happening here. Look how big this sucker is.
Yeah, it's huge. It has a pink edge.
Yeah.
I've seen simulators that have a pink edge, but this is no simulator.
I've never seen a webcam capture without the distortion of the lens flare and distortion in the back apparatus. Look at this. Wouldn't it be almost overpowering the camera? That's what I'm thinking.
Yeah, but it's not. So it's not that bright.
No, exactly. The looms on it are not that big. So there you go. Look at that, Claudia.
Yeah, it seemed to change shape again at the bottom there.
Look at that. So if that's our sun, okay. But I've never seen.
I need to write an article on this.
I'll send you this video.
Thanks.
I have it. I'll send it to you. And I'd love to see your analysis on this because we've taken, 10, 12 minutes of the viewer's time. But I thought that this was important, Claudia, because you know what? When you look at this, it's almost as if I can see the corona of the damn sun.
Yeah, well,
happened?
These objects act a lot like very small sun. I mean, it would have been quite small to be so close to the volcano that it actually reacts to the volcano. It would have to be a small object, but bright, having plasma around it.
Look at this. And I understand distortion of pollution and everything else, but you could get a magnifying in which you can do this, capture a frame of it. And I swear I'm almost like I'm looking at Soho, looking at the corona.
Sorry, Wayne.
This here?
Yeah.
Well, this started out as what I called the lens flare. But, we'll let it suffice to say that is, I don't know,
But then it should move as the bright object moves.
It should be on top, but it's, it has a reaction to it. Isn't this odd? I mean, if I was sitting on this volcano, you'd almost be down on your hands and knees going, I mean, this is amazing, isn't it?
It is amazing.
Yeah, I thought you would find this.
I mean, I am so surprised at this. I never expected anything like this.
Yeah, and even buffering, accounting for the buffering of the frames on the video, we're still getting an aberration of the sun or whatever this object is. There we go again. We have the extension.
It's flashing. Yeah.
Yes, exactly. It is. And I counted the frames on this. And the thing about it is it's not rhythmic. It is variable, which tells me that it's not artificial.
Yeah, you're right. If it was a device, it would be changing brightness at regular intervals.
Yes. This one seems to be sporadic, and it seems, because you can see it here. You can see it at times where, I'm going, okay. So I just thought I would share that with you.
Yeah, that's amazing, Wayne. I am so surprised. It's beyond anything I expected to actually have an object reacting to a volcano like this. And being this bright.
Yeah. And you look at this, folks, and if you copy this, you could actually see, just follow this. I mean, you could do a simulation of what the corona would look like from an Earth perspective. So it's a great video. These
objects basically are acting like small suns.
Yes. Yeah. That's what my point was. Maybe the good folks down in Mexico, listen, they've got some weird stuff going on down there. The last earthquake, November, the 8-pointer cracked the mantle. So you have portions of Mexico that's sitting on a fractured mantle. I mean, it's so, yeah, look at that. Isn't that weird?
That is so strange. It's connecting with that blue thing there, which...
Whatever it was.
Oh my, I need to analyze this very carefully.
I will send this to you. And yeah, it's
my goodness.
It's just different.
No, this is new data. This is new observational data that has to fit in with what, I have discovered up to now using the observational data I've had up to now. This is over the top.
It's weird, isn't it?
It is.
In my day, we would say far out. Because it really is pretty far out. I mean,
it is. This is amazing.
And as like I said, you go to the beginning of the video, we can see that the sun actually did a U-ey up here and then came back down.
Yeah.
I mean, that's what kind of went. I went, well, how about that? And
now it's just remaining there. It's not actually moving at a constant speed. It moved down and then it sort of stayed there.
Yeah, it's like, hi guys, how you doing? I'm just hanging around. Got a beer? Got a joint? Come on, I'm down here in Mexico,
Yeah.
Yeah, I mean, so I'll send this to you. It's just, and here's the odd distortion. Look at here. So we're getting a distortion effect here. Now I could say, all right, well, this is part of the mountain. The mountain goes up here. But it's still, the aberrations of the camera is interesting. I thought you'd like this.
This is absolutely, I'm flabbergasted.
It's weird. I knew you would like it. And I thought for myself, well, why not?
It's amazing because I'm going to have to rethink how these objects work, how they end up. Wow.
And the thing that I guess that I'm kind of puzzled about is I don't understand the U-ey it made. I mean, the camera stays stationary. So the celestial object that the camera is picking up, it's the one that's moving.
That's
you know.
right.
Yeah, I mean,
Absolutely.
so I'm going, well, now an object should be able to go on a plane of the arc, of which that's what it's designed to do. That's what we're told it's supposed, right? I don't know.
Yeah, but this object, in order for it to point directly at the volcano, it had to be very close to the volcano. You have to realize that. It had to be inside the Earth's atmosphere. So it's a small object. It's very bright. It has magma around it, but it's acting like the sun.
Mm-hmm.
Which is not surprising because, as I've discovered, all celestial objects, no matter what the size, work the same way. So basically, a planet is a star on the inside.
Yeah.
A small star on the inside.
Yeah. So thank you, viewers. Appreciate it. And I think I got Sin's right name. I think I got everything. If I didn't make your name properly, let me know. Now, Claudia, I know I wanted to share a little something else that I think more evidence of the changing planet that we're on. This is the sun. So this is this island out in the Pacific. Hunga Tonga. We have great views of the ocean. So in 4 years, look what happened. I mean, this is permanent. It's, I think, more evidence of just the land changing. I found this odd in nature. Wow. This is a squirrel, Claudia, a flying squirrel.
Oh my goodness.
Claudia, they find the scientists, these are secretly pink and they glow in the dark.
Wow.
How does that happen?
I have no idea. How is this even possible?
I don't know. It is the
something's happening to the planet, maybe, that it's even changing what the animals look like.
Fluorescent patterns are now visible under ultraviolet light.
Oh.
This is strange. Now, Claudia, I don't know if the Chinese got something up there or not, but this is what I did find interesting. They are now recording temperatures on the dark side of the moon, minus 310 degrees Fahrenheit. I didn't know it got that cold.
Absolute zero.
Exactly. I mean, absolute zero is what, minus 454 degrees Fahrenheit, or is it? I know it's right in that range.
Minus 373, I think. I can't even remember, but it's in, I don't know it in Fahrenheit.
But this is remarkable. I did not know.
Yeah, it's nearly minus 400. It's close to minus 400 Celsius.
This is incredible. You think about it.
The moon is not supposed to have much of an atmosphere. So you would suppose that, the temperature when it's dark, it's supposed to be very close to absolute zero, I'm sure.
I would think. So anyway, I don't know if they're really up there or not. This one I brought out. So the volcanoes that are underneath Antarctica are now, we're about to see, they said, the largest shelving of the ice shelf down there, which gives you the distortion that you think Antarctica is actually, melting off vast amounts of ice. They are, but they're also gaining amounts. But again, changes on our planet all over the place.
Yes, it's the North and the South Pole that seem to be getting much warmer than anywhere else.
Definitely.
Yeah.
So this is what hit you last week, and there is another one coming. I wanted to show this model. So folks, hold on to your hat here in North America, because here is what the vortex is, that normally what we would see. It should be more up here, but this is where it's split now, Claudia. So the United States, get ready. It's going to be cold again. how about this one, Claudia? You and Scott did a story on this. This
Mm.
was the one that hit in the Philippines last year, last September. Remember you and Scott showing how the upheaval and the specific cracks that were done? You did a paper on this as well.
Mm-hmm.
Well, now they're saying that this was what they are calling a rare super shear event. Fewer than 15 of these super fast moving, extra powerful earthquakes have ever been identified. This is
Mm.
why they're finding places in India where the ground is literally smoldering, embers. Yeah, so there is some serious size.
Yeah, there is some serious, but they like to say that this is all about the earth doing it by itself. Something's
Yes,
happening inside the earth. But the thing is, it's caused by the objects that are approaching the earth. Just like the CMEs on the sun were caused by these objects. So they like to find some other way of explaining what's happening to the earth. But the thing is, like I like to say, there is a cause for every effect. And what's happening to the earth is due to the Planet X objects that are approaching it.
exactly. And I have some of your articles. I know this is a little that we don't typically get, but this one I thought was just so weird. So the superhuman robots are going to be able to outstrip everything that we do as humans, they say in 50 years, Claudia.
Mm-hmm.
I don't know about you, but
Yeah.
it just, I don't like what I'm seeing. I'm seeing the days of Noah here almost.
I
Uh,
think you're right. I don't like AI. I think they are dangerous. I've written several articles about that. I don't think they have the same ability as a human being, not even close, because human beings have creative thinking abilities that AI cannot possibly emulate.
Thank you. And this is the one that concerns me most. When you start now having experiments that are creating gene edited human embryos,
Mm,
this is this is no different than in many of the ancient uh, stories of interfering with life. And
that's
it
right.
gets the last story on this one, Claudia, just I just couldn't believe. So you got some guy now in California who is selling gene editing kits to the public.
Oh my goodness.
Exactly. That was exactly my response. What? And you know what he said? He literally said this in the article. He said, well, I think it's good that we could start creating, new monsters, rarefied breeds by people, everyday people. I'm going, did you not read the story
That
about Frankenstein? Did you not get what they were talking about?
that is ridiculous. It's like you're trying to kill yourself. You're trying to kill your own species.
Yes, ma'am. Thank you.
What are these people thinking?
Ay, 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 ay. So, Claudia, I have one of your papers and I'm going to pull them up one at a time now so
Mhm.
I don't lose them anymore or get shut down on the, I don't know. I'm saying that it was potentially over zapping my computer. So, I loved this article
Oh,
because,
about visible light. Yes.
yeah, the visible light spectrum.
Yes. I mean, I suddenly started looking at it and I realized that violet. I mean, I started out looking at this photograph here where you can see violet at the top and it becomes pink at the bottom. And I know from what I've observed that what we have is electron levels in the atmosphere, where higher up you have electrons that have more energy, and the energy they have in them is actually photons. So you get the violet electrons, and below that, electrons that have a lower energy. So they have a photon in it that is of a lower energy. So that means that pink is a slightly lower energy than violet. And then I realized, but wait a minute, but pink is a mixture of red and blue. So that means that and violet, as it turns out, is exactly the same as magenta, because we usually say magenta is pink, which is a mixture of red and blue. But wait a minute, but violet is also magenta. It just has more blue in it than the pinker part. But then that means that's a complete red to blue spectrum in there. So what it means is, and we can move down, and where I actually draw.
Oh, look at this.
First of all, I say, look, violet and pink or magenta is actually the same thing, except in the pinker part, you have more red, and in the more violet part, you have more blue, but it's the same color, basically.
Yes.
And then I used the spectrum and the different frequencies, which have associated energies. And then I did take out the orange. I think I'm going to write another article, and I'm going to put in the orange because I've discovered something about the orange. But basically, we have red to blue. That's the visible light spectrum. And now, if we add green to red, we're going to get yellow. But that means we get something in between the red and the green. Mm-hmm. And if we add green and blue together, we get cyan, which is that one at the 600 terahertz.
Right here.
Terahertz mark. Okay. So that's the cyan. It's the blue-green. And it's in between as well. But if we add red and blue, we get something of higher frequency and thus higher energy. We get the violet.
Yeah.
So there's a difference between what colors we add. If we add green, we get something in between. So we don't get the sum of the two, basically. But if we add red and blue, we get the sum of the two. So that means that there's something special about the red and the blue. They somehow, and I called it a phase, they have a higher phase, or a higher vibrational level. But there's another part to the frequency. It's not just about adding frequencies. There is something else in the colors, and I called it a frequency phase. But what it means is that we human beings actually see two full spectrums. We see the visible light spectrum, and we see the violet spectrum. It's two different ones. So the first one goes from red to blue, and the second one goes from pink to violet.
All right, here.
Yeah, the pink to violet. That's so those are the two that we see. And then, but that suggests that even those that we do not detect go in the same way. We're also going to get, and we have, you see, I drew the phase there. So the green frequency in the middle has a lower phase. It almost looks like a wave.
It does.
It has a low phase, whilst the red and the blue on the edges have high phases. And I've drawn there a straight line right through the violet because I expect it to be a high phase as well. But as it turns out, there is a middle to that spectrum as well, and it's the peach color. I've just discovered that. I haven't written the article on that. So there's going to be a dip between the pink and the violet as well. It's going to be peach. And but this is associated with what we see in gravity itself, because gravity creates wave patterns on the surface of the ocean created by the stellar cores, which interact with the water through the gravitational interaction, which has bulges, and in between the bulges, it's got little hollows. So that shows the bulges are the positive phase and the hollows are the negative phase. It's exactly the same as we find with photons themselves, with light itself, because gravity is due to light within the particles. So we get exactly the same pattern. And this, by the way, would lead to us having hollow shells inside planets, because there will be the areas where gravity reverses, just like because of the negative phase of the photons.
Is this indicating a shift in the atmosphere itself? I mean,
In this case, it's because the stellar core, it's not in the atmosphere. This is light itself. This is how light is, how the different photons are. So you get photons that have low energy. These are infrared photons, which the surface of the Earth emits. And above that, we get the visible light photons. And the visible light photons are the only part of the whole of the light spectrum, from radio waves all the way up to gamma rays, that human beings can detect.
You know, as you were saying this, Claudia, that rainbows are changing colors.
Yes, but the rainbows that I think we are seeing in our skies are not produced in the same way that they used to be produced.
Okay, yeah.
Yeah, most of what we're seeing in terms of rainbows are due to electromagnetic artificial devices that refract light. But the colors of the clouds are changing. We used to have gray and white clouds. Now we have pink, purple, blue. I haven't seen many green clouds. I just saw a little bit of green in some noctilucent clouds.
Mm-hmm.
The other day. I'm still going to use that in an article. I just have so much data, I haven't had time. But what it means, this is what we haven't been told. So far, we were told we see the visible light spectrum. We were never even given a hint that as we add different frequencies of photons, we're going to get different effects.
Yeah.
It seems that no one has ever even thought of that, even though we can see that clearly now, just from the colors in the sky. No one ever told us that violet is actually magenta. So the lie has actually been magenta is something apart. We never see magenta. And violet is actually part of the blue. So this is how we've been taught about the visible light spectrum. We've never been taught about adding photons and getting other photons, like adding red and blue and getting the violet part of the spectrum. And that means we can go all along the whole spectrum, say we want to get ultraviolet light. We could just add different visible light photons together until we get ultraviolet light. That's what it suggests.
Claudia, would we also be seeing evidence as well in this, as which I think we're seeing as the magnetic pole reversal? Would we expect to see evidence as well with the stellar cores coming in that would, I think, have potential visual impacts in the atmosphere as well?
There are two parts to that. First of all, the stellar cores absorb energy from the Earth. All the colors we are seeing, and whether these objects are emitting light or the clouds are emitting light, it's all coming from inside the Earth. This is due to gravitational energy that's being drawn from the center of the Earth, from the Earth's core. So when we see colors like that, we are seeing energy from the Earth's core, which these objects are drawing out. That's all.
Would make sense.
That's Earth's energy.
I look at it like this. I like baking, and sometimes you have to shift flour. And as you're sifting the flour, it's the same process. I have flour that is what I would call the Earth's core, but as I'm shifting it, there's a transference of energy taking place.
Mm-hmm. That's very good. Yes.
Yeah. See.
Definitely. So what we are seeing here is photons that originate within the Earth's core and are being drawn out, and they come out of the center of the Earth in the electrons.
Mm-hmm.
And the electrons have photons in them. That's the energy that's inside the electrons. And then as they settle into atoms the photons are released. That's why matter emits light. But all that energy came originally from inside the center of the earth.
You just said something, and I got to tell you, you have added so much to my, in one way, in knowing who I am as a spiritual being. But you said something. So for material to manifest itself in this realm is really the taking photons and making them visible, right?
Mm-hmm.
That's deep.
That's
deep,
right.
Claudia.
So they are the photons that we see are
Yep.
first inside electrons. We don't see the photons inside the electrons. Electrons are particles. But when they go, that's what I show there. When they go inside an atom, they release the photon, and then it becomes a photon that can hit our eye, we can see. And this is what occurs for a cloud. A cloud is not positively charged. It's polarized, which means it's more positive on one side than on the other. But it's basically a water molecule is neutral. So the reaction that causes a cloud to absorb energy has to start with photons themselves. So there has to be some light in the atmosphere already. It could be coming from the simulators, or it could be coming from other matter that is emitting photons. The surface of the earth emits photons, infrared photons. We do not see them, but they're still photons.
Right. Just like cosmic rays, we don't see those.
Exactly. So first of all, the photons go in and are absorbed by the electrons that are inside an atom already. They are in an energy level. Eventually, that photon gets so much energy that it just has too much energy to stay in its energy level, so it leaves. So once that electron leaves, it leaves a gap. And then electrons from the atmosphere that have photons inside them go into that gap. And as they go into that gap, they release the photon that was inside them. So that's when the cloud emits light. And at the same time, some of that energy got absorbed by the material. So some of it ends up in the nucleus because there is a gravitational interaction. It's like a curved line between the two particles. I've drawn it in one of my articles, connecting the two particles. And through that, there's energy transfer from the electron to the protons and neutrons in the nucleus. It's through the gravitational interaction between electrons and protons.
So the photon is a result of the electron entering into the atmosphere in this cavity, this space in between here, right?
Yes. So when the electron is captured, goes into an atom, it releases the energy that is in excess for that energy level. And that's the photon that gets released.
I never knew an electron could actually give birth.
I know, isn't it amazing?
You ought to write a paper on this. I mean, I just now dawned on me. It's wow.
You see, this is how the whole universe works. It's energy within particles, particles within energy, and how it all works from the inside outwards.
Yeah.
So energy from inside the core of the earth gives rise to all these things that we then see. Energy transfer mechanisms, light being emitted. That's how it works. And it works in the same way everywhere in the universe at all levels.
This. If I'd had you as a, my calculus teacher, I probably would have made better grades. The one I had was boring.
Well, calculus, the only way to learn calculus properly is to practice.
Yeah.
So when you get a whole lot of exercises and you find yourself having fun solving all these little calculus problems, like, little puzzles, then you're going to get really good at calculus.
You know what? I found it to be redundant.
this is how you teach,
I know.
you know.
And the guy I had was an asshole, but he also thought I was one. So anyway, I digress. So
Yes, I digress too.
so as we continue on, this is so interesting. So this is the field that I gather that what we're seeing here represented through this graph.
Yeah, so these are the electron energy levels in the Earth's atmosphere.
Mm-hmm.
So the lowest energy level is the infrared electron energy level, which encompasses the top surface of the Earth and just above the surface. That's where we would find infrared electrons. And if there's any matter there, when the electrons are absorbed, what's given off is infrared photons, which we do not detect.
Right.
But that's what will be there. And then higher up at a cloud altitude, we start getting the visible light electrons. So if there's matter there, if there's cloud there, that's what the cloud's going to emit, visible light. That's where the blue part of the sky is. The nitrogen layer in that area, the nitrogen molecules, when they absorb electrons, they give off blue light photons. That's why the sky looks blue.
Interesting. Okay. So we're seeing also a chemical reaction between, I wouldn't say elements. Yeah, I guess that would be, wouldn't they?
It's chemical reactions, because the moment you have reactions with electrons, you have chemical reactions.
Interesting.
What you're getting is atoms becoming ionized and then absorbing electrons again. So that's basically a chemical reaction. It's not a nuclear reaction. You want to get nuclear reactions inside the core of the Earth. You get fission, where nuclei will fission into two parts, and that gives off energy from the nuclei itself, the nucleus, the protons in it, where some of the mass gets transformed into light, gamma rays. These gamma rays can be transformed back into matter. Those are the matter creation reactions that occur there. But in the atmosphere, and let's go back to that, because I wanted to mention something important. When we get lots of dense matter in the atmosphere, the ultraviolet energy level altitude and the X-ray altitude, what's going to happen is this matter is going to emit ultraviolet and X-rays. And this, I believe, is why we are getting more and more ultraviolet radiation on our planet. It's coming from our atmosphere because there's more and more matter at those altitudes because of the Planet X debris.
Interesting.
And as I've written in several other articles, this means that our Earth, our atmosphere is heating up. It's emitting more and more radiation. It's becoming like Venus.
Yeah.
And it's going to become an inferno.
Well, that's not very positive.
I'm sorry, but that at the moment it's still possible to get cold on the lower part of the atmosphere, but I am quite sure that the upper atmosphere is getting extremely hot at the moment. And as the Earth loses energy, these electron levels will move down, further and further down. So this hot part of the atmosphere will move further and further down because there's so much radiation. When there's a lot of matter, a lot of radiation, a lot of the matter, as it absorbs more and more radiation, gets hotter.
Well, you know, and point on this was what we saw in the aberration of the polar vortex was because the North Pole warmed up. I mean, when it started hitting temperatures 50, 55, 60 degrees where it shouldn't be that warm, this is what throws the whole thing off. So,
yeah, you know, when I think that what we're seeing on our planet is artificial.
okay.
They actually planned that to cause that cold movement of air, which you call the polar vortex, down to those low altitudes. And they are purposely heating up the poles because don't forget they have sun simulators, and sun simulators are used to ionize and heat the atmosphere. So they can heat wherever they want.
They've admitted they do have ionized heaters for the atmosphere.
Yes.
Yeah. Now we're getting a lot of these kind of pictures, which, we see them here in Colorado. They're very bizarre. I can't, how you're getting the sun reacting in the light here.
Yeah, you see what we have there. Most people will look at that and think, oh, that's a shadow. But that cannot be a shadow because remember, a shadow is absence of light. We do not have absence of light there. We have a blue section of the atmosphere, which is blue.
Yeah.
So that's not a shadow. That's a projection. Blue light has actually been projected onto that section of the atmosphere. And you can see two little clouds below it. One is lighter blue and one is pink, almost reddish pink. Below it. That's not part of the projection because it's below it. And the projection is above that. So I think what this is a holographic projection onto the sky, and it's designed to hide things like those colored clouds. Because, it takes a while for us to even notice there are these clouds there because you're so busy looking at all the colors everywhere else.
Yeah.
That
the vast majority, and most people wouldn't even notice this.
Exactly.
Yeah, they look up at it and going, all right, yeah, because that's how people are.
Mm-hmm. They do that on purpose because that's what they do. They're trying to hide certain things from our eyes and making others to seem normal.
Now, that's weird.
Yes, look at that. It looks like a break in the clouds, doesn't it?
It does.
It looks like a blue break in the clouds. But if you look carefully at it, I'm not sure if it's very clear, but it's actually convex. It curves downwards, that blue surface. So it's a spherical surface we're actually looking at. It's not a break in the clouds at all. What it is actually a stellar core in the atmosphere. What we see around it, that's it poking through its cloud envelope. That's the bottom part of it, or its south pole, basically. And the cloud that we see there, it's part of its cloud envelope. And the cloud is emitting this pink, and it looks gray in places. Gray parts are parts where there aren't many photons coming off it. So that's where the cloud, the electrons going in are just at the right energy not to emit light most of the time. But the blue object, I thought first, when I first saw this, that it was probably reflecting light emitted by a sun simulator emitting blue light. But now I think actually the surface of the stellar core is emitting blue light. So in other words, it's absorbing electrons, visible light electrons, blue light electrons that are then emitting blue light.
That is wild.
Blue photons, yeah. So the surface is emitting blue light.
Wow.
And the cloud envelope around it is emitting different colors, the pink, the white, some parts of gray.
Wow. What an hour.
It's amazing. What kind of a planet are we living in? It
seems to be very volatile.
Yes.
Doesn't it?
Very strange, very strange. Our educational system prepared us to reject all this. That's what it amounts to.
Yes.
We were educated to see these things and reject any possible explanation like the ones I've given you.
Yes, I agree.
Basically, we've been brainwashed not to believe the truth about what we are seeing.
And what I can't get over is how readily it's rejected. and you can't get people to even think outside of this imaginary line that they won't cross.
Yeah.
Oh no, I don't see anything. I've had people have seen it. I'm going, do you see that? No. All right, what am I on,
I mean, the physicists will not see it. They will close their eyes to something like this.
I've been doing some reading, Claudia, on history, and wow. I mean, the repression in science is as bad as it's been in repression in any other area, whether it be political, religious, or whatever. It's quite amazing.
It is. It's very sad, but we've been taught lies. I mean, just look at our visible light spectrum.
Yeah.
Why hasn't a physicist come along centuries ago and figured this out about light? I mean, I can't believe it sometimes. Why do they teach illogical facts? And no one figures it out that it's illogical. How is it possible?
Well, because many of those scientists realize they lose their head.
Probably.
As your career. I mean, again, you're such the beauty of what you provide us is that it's a perspective of, well, science that is still science. And that's why even your peers, they can sometimes want to attack, but in the very end, they have to agree.
Yeah, I think they would be too scared even to.
Oh, granted. I think that I let me tell you, I know you have a number in the field, in your field specifically, that do admire you. It's just that they're too coward.
I'm not sure. To tell you the truth, I think they might be too afraid to even watch my videos, a lot of them, because they're being watched.
Yeah, that is so true, and it's
but
sad.
It's possible that some do. I think some might, few, but
the way I look at it, at least we're educating those that are watching.
Yeah. I think there might be retired physicists that might watch, because
I know of a couple. So.
Okay, good.
Just to let you know,
Thank you.
Do watch you.
Oh,
well, Claudia, thank you. What do you have coming up? Anything on your channel? I know you constantly put out videos, folks, so you need to make sure that you're subscribed to Dr. Albers' channel, and hit that like button and hit the notification button as well.
Yeah, I'm writing a few articles about wormwood because I noticed that people have questions about that. So
yes, a lot of confusion on that.
Yeah, so I'm writing some articles, and I've actually started from the Bible, Revelation chapter 8, and I read through it, and I said, well, this is what I think it is, and I explain it. It's basically a Planet X star, a Planet X system star, and it must be a large star that comes to Earth, and it affects the Earth in several ways. And wormwood itself, to me, it was a large piece of the debris. So 3 different parts of the debris affect the Earth, and you can see it in the first 3 trumpets.
Folks,
I'm writing about that.
Check it out.
Yeah.
Well, Claudia, have a great week, my dear.
Thank you. You too.
Got my best. And,
I will. Thank you.
We'll see you next Monday.
My best to Lynn.
She's standing right over there, and I'll tell her.
He's waiting for you. Sorry, I kept you.
No. Claudia, it's always a privilege. Thank you so much. You again, I tell you, you're a national treasure, and that's just how I see it. So, all right, everyone, we'll see you back here next Monday night. And Claudia, thank you again. Thank you, all the moderators and everyone that's been here tonight. Thank you. My
pleasure. It's been wonderful. Thank you.
She's far out, folks. Y'all really need to go over it. Claudia, I'll see you later, hon. All right, everyone. Good night.